Okie dokie. Let's look at question 11, right? So this question says two triangles are drawn with the radius of r, and the center of each lies on the circumference of the other circle. So we put that is a center and that is a center, right? Therefore, the distance between them of the two, that's this, is r, right? Okay, and then we have, let's call this point A. Let's call this B. Okay, and then we have this intersection point over here, this intersection point over there, right? And we can call this AB. This is R. This can call this C. We can call this D, right? From there, what do we want to do from there, right? They say find in terms of R the exact area of the shaded region, right? So if we say this is the shaded region, okay? Now, let me see if I can make this a bit thinner. It's as thin as it can get. Sweet, no problem. All right, so if you were to, how are we gonna go about solving this? All right, so let's just look at from here. From here, we want to draw a line there. And I'll just do this. We want to draw a line from here to there. Okay. And then let us know that, let us see that. I want you to notice that from line A to C, AC is equals to R. And then remember AB is also equals to R. And BC is also equals to R. So they're all equal, right? And that becomes an equilateral triangle. And you remember from way back when, that means the angle between here, and there are all 60 degrees, right? And if you look at this, I'll put this in another, so if you look at this, right, in another color, that is a pi right there, okay? That's one pi. And then if you look at here, that is another pi, right? Cool. Now, so it's also going to be at the same, right? At the bottom, right? So if we were to draw this was in black, and then that, right? And from there we have another pi. I just want to see it now. This is 60, right? So it will be from here. It's from here this way. Let me draw it in the same colors. That's red. That's one pi, and blue. That's another pi, right? Okay, I hope you can see that. So we have 4 pi's over there. So 4 sectors, okay? So what we want to do is, all right, since they're all equal, all right, lengths are equal, what we want to do is let's find the area of one sector, right? And that could be A, B, C, right? And then we can find the area of an equilateral triangle, okay? And once we've done that, right, of this triangle, right? So what we want to do, let's do this. Find area of ABC sector, then find area of, again, ABC triangle, right? Cool. Now, so what we're gonna do, we're gonna now say that once we found the area of the sector, and I want us to see that like all the sectors have the same area, right? Same angle between them and the same length, right? So Once we find the area of the sector, what we're going to do is then, I guess, subtract maybe one of the equilateral triangles, right? Then we can double it, right? So if we find the area of this one, the one in blue, right? And then subtract this triangle, right? Then we have this, right? You can double it. Okay. So let's do that. Right. So what's the area of sector A? ABC is going to be equals to, what is our area of our sector again? Can go to your textbooks. Remember the area of a sector. Okay. Area of a sector is going to be half r squared that, right? And what is this? Okay. So, but do we have the radius? Do we have the angle? We do. We do. Right? So this is going to be gonna be 1/2 times, what's the area, what's the radius? They didn't give us the radius, so this is r squared. What's pi? Let's do it in radians. Let's use it in radians. I know that this is 60 degrees times 180. I'm gonna move it, so it's gonna be pi over 180, and that's going to be pi over 3, right? So the area becomes r squared pi over 6, okay? And then what we want to then do from there is now find the area of our triangle. So what's the area of our triangle then? The area of our triangle, okay, we have an equilateral, right? This is R, this is R, this is R. Okay. And then if we were to find this, so that we use half base times height, or like before, half AB sine C. Okay, from our previous question. Yeah. Okay. And that's going to be equals to 0.5 r squared multiplied by sine of, what is sine? Sine of, let's put it in radians. We're going to put our calculator in radians. So we're going to say sine of pi over 3. And that gives us, sorry, not pi over 3, pi over 6. That gives us 1/2. Okay. That gives us 1/4. Okay. I think we're missing something, and let's just put it in. So this is pi over 3, the angle. Oh, it's not pi over 6. Excuse me, it's pi over. Yeah, that's where I made the mistake. It's not, yeah. So this is going to be equals to half times r squared times, what is it now? Sine pi over 3. And that gives us over 2, that gives us r squared 3 over 4, okay? Now, what we have to then do is now say, where is our sector area? So our sector area is going to then be okay. Like I said, we double our sector. So that's going to be 2 pi r squared over 6 minus r squared pi 3 over 4. And then we multiply this by 2, right? And then that becomes 4 pi r squared minus r squared 2, 3, and this is 6, this is 4. Okay, can we do some simplification? This becomes 2, this becomes 3. Nah, to be fair, we're just going to go back to this. Yeah. Oh, actually, no, sorry, what am I talking about? So this becomes 2 over 3 pi r squared minus